In this class, we are going to discuss about the next important economic function, that is cost function. We know that the cost function explains the technical relationship between the cost and the output. That is, the relationship between the cost and output is described as the cost function. The production function and the price of the inputs together determines the cost of a commodity. Therefore, the cost functions are derived from the production function. That is, the production function and the prices of the input determines the cost, and therefore the cost functions are derived from the production function. And the cost function can be represented as follows. See, a function of Q, output produced, various inputs, price of the inputs, etc., technology, capital, etc. Usually the cost function is expressed as a functional relationship between the cost and the output. All other factors, all other variables are kept constant. There exist different types of cost. The first one is the explicit cost. The explicit cost are the actual expenditure which are used by the firm to purchase or hire the inputs. This expenditure includes the wages to hire labor, interest on borrowed capital, rent on land and building, the expenditure on raw material and finished materials. These are the explicit costs that are actually incurred by the firm. Second type is the implicit cost. Implicit cost refers to the value of input earned and used by the firm in its own production process. That is, the value of these owned inputs must be imputed or estimated from what these inputs could earn in the best alternatives. That is, the implicit cost means the cost of inputs earned by the firm. And next the difference between the implicit cost and explicit cost is that in the case of the explicit cost, it may be written in the case of the explicit cost, it is written in the it is accounted in the production process, whereas in the case of the implicit cost, that is, if the owner himself is the manager or he himself act as the laborer or he himself serve as the laborer, and if he is not taking the wages, etc., that types of the cost are termed as the implicit cost or the cost. Another important cost is the opportunity cost. The opportunity cost of producing a particular good is the cost in terms of other goods which might have been produced using the same resources. That is, it is the cost of the alternatives. Another term is the total fixed cost. This is the total obligation of the firm per time period for all the fixed input. This include payment for renting the plant and equipment, most kinds of insurance, property tax, salaries of the administrative staff. These are fixed input. These are the cost for fixed inputs. Then the next important type of cost is the total variable cost. It is the total obligation of the firm per period for all variable inputs of the firm. These include payment for raw materials, fuels, most type of laborers, excise taxes, and so on. These are the costs for variable inputs. Next is the average fixed cost. Average fixed cost equals total fixed cost divided by the output. That is, total fixed cost divided by the output is the average fixed cost. Likewise, the average variable cost equal to the total variable cost divided by the output is the average variable cost. And the average total cost is obtained by dividing total cost by the output. It is also defined as the sum total of average variable cost and average fixed cost. That is, average total cost equal to AFC plus ABC. That is, it is the sum total of average fixed cost and average variable cost. Another one is marginal cost. Marginal cost is defined as the change in total cost which results from a unit change in output. It is the slope of total cost curve. That is, marginal cost is the change in total cost as a result of the change in unit output. Then planning curve. The long run cost curve in the planning. The long run cost curve is the planning in the sense that it is a guide to the entrepreneur in the decision to plan the future expansion of the output. Another one is envelope curve. The long run cost curves are called envelope curve because it envelops the short run cost curves. That is, the long run cost curves are usually known as the cost curves are usually known as the envelope curves. A brief explanation about the costs that we have already discussed is given in this section. That is, the first one is total fixed cost. Total fixed cost refers to the total money expenses incurred on the fixed inputs like plant machinery, tools and equipments in the short. That is, total fixed cost is the cost for fixed inputs of the firm. It remains the same at all levels of the output in the short run. That is, the total fixed cost remains the same in the short run. It is the same when the output is nil. When the output is zero, the total fixed cost will be the same. It indicates that whatever may be the quantity of output, total fixed cost remains the constant or the same. It is a horizontal and parallel to x-axis. Total fixed cost is horizontal and parallel to that means it is constant. Regardless of the output may vary, but the cost remains the same, and the total fixed cost will be there even if the output is zero. Then second one is the total variable cost. Total variable cost is the money expenses incurred on the variable factors like raw material, power, fuel, water, transportation, communication, etc. in the short run. It is obtained by summing up the production of quantities of the variable inputs multiplied by their prices. That is, TVC equal to TC minus TFC. And TVC a function of the output. And total variable cost is an increasing function of output. In other words, total variable cost varies with the output. It is nil if there is no production. Thus, it is a direct cost of output. That is, the total variable cost increase as output increases. It is nil if the output is zero. Total variable cost rises sharply in the beginning, gradually in the middle, and sharply at the end in accordance with the law of variable proportion. That is, the total variable cost increases sharply in the beginning, then gradually, then sharply. This is the increase in the This is the change in the total variable cost in the production process. And total variable cost curves are given in the figure. It increases from the left to the right. When output is zero, total variable cost will be zero. Next cost is the total cost. Total cost refers to the aggregate money expenditure incurred by the firm to produce a given quantity of output. Total cost refers to the aggregate money expenditure incurred by a firm to produce a given quantity of output. The total cost is measured in relation to the production function by multiplying the factor prices with their quantities. That is, TC a function of output. In the case of the total cost also, it varies with the output. This total cost includes both implicit and explicit cost. Therefore, total cost equal to total fixed cost plus total variable cost. Total cost varies in the same proportion as the total cost. Total cost varies in the same proportion as total variable cost. In other words, variation in total cost is the result of variation in total variable cost, since TFC is always remains constant. Here, this is the total cost, this is total variable cost and total fixed cost. Since this total fixed cost remains same or constant, the total cost varies in the same way as the total variable cost. It is given in the figure. Another term is the average fixed cost. Average fixed cost is the fixed cost per unit of output. That is, it is obtained by dividing total fixed cost by the total units of output obtained. AFC equal to TFC by AFC. TFC by total fixed cost is obtained by dividing average fixed cost is obtained by dividing total fixed cost by the total units of output. AFC equal to TFC by Q. The AFC and output have inverse relationship. It is a pure mathematical result that the numerator remaining unchanged. TFC spread over each units of output, and therefore AFC diminishes continuously. AFC curve goes very near to the x-axis but never touches the axis. It will fall steeply in the beginning, generally in the middle, and tends to become parallel to the x-axis. As output increases, AFC diminishes. That is, average fixed cost is the total fixed cost divided by the output. That is, it is the per unit of output fixed cost. Next cost is the average variable cost. Average variable cost is the variable cost per unit of output. It is obtained by dividing total variable cost by the output, or AVC equal to TVC by Q. AVC will come down in the beginning and then come down in the beginning, then rises as more units of outputs are produced with a given plant. This is because as we add more and more units of variable factor in the fixed plant, the efficiency of the input first increases, then this is it is the U-shaped curve, average variable cost. Next one is average cost. Average cost refers to the cost per unit of output. It is also known as unit cost. It is the cost per unit of output produced. It is the sum total of average fixed cost and average variable cost. And average cost equal to TC by Q, or AC equal to AFC plus AVC. It is also of U-shaped, and it had the combined influence of the average fixed cost and average variable cost determines the shape of the average cost curve. And AC equal to TC by Q, and or here TC equal to TFC by TVC. Then we can rewrite this equation as TFC by Q. That is AC equal to TC by Q. Then TC, substitute TFC plus TVC with the TC. Then this AC equal to TC by Q will be equal to TFC by Q plus TVC by Q. What is TFC by Q? TFC by Q is nothing but the average fixed cost. TVC by Q is average variable cost. Therefore, AC or average cost equal to average fixed cost plus average variable cost. Both average cost and average variable cost are U-shaped. Next cost is the marginal cost. Marginal cost may be defined as the net addition to the total cost as one more units of output is produced. In other words, it implies the additional cost incurred to produce an additional unit of output. It is the amount needed to produce an additional amount of output. If it cost rupees 50 to produce 10 units of the commodity and 55 to produce 11 units, then marginal cost would be 5. It is obtained by calculating change in total cost as a result of change in output. That is, marginal cost equal to delta TC by delta total cost, delta TC by delta Q. Or it is the derivative of the total cost function, this which can be written as MC equal to DTC by DTQ, where DTC stands for change in total cost and DTQ stands for change in total output. Or we can write this as marginal cost of end units equal to total cost of end product minus total cost of n minus 1 product. This is the next one is the long run average cost curve. Long run average cost is the long run total cost divided by the level of output. It is the per unit cost of production of different levels of output by changing the size of the plant or scale of production. The long run cost output relationship is explained by drawing the long run cost curve. This curve explains how the cost will change when the scale of production is varied. The long run cost curves are influenced by the laws of returns to scale as against the short run cost curves, which are subject to the working of the law of variable proportion. Here, the long run cost curves are, this is known as envelope curve. It is envelope. These are the small short run average cost curve. This is the long run average cost curves are the analogues of the short run average cost curves. In this figure, different cost curves that we have already discussed are summarized. This is the marginal cost curve, then average fixed cost curve, average variable cost, average cost. These are the important cost curves in economics. In this section, the relationship between average cost and marginal cost are explained. There exists three relationships between the average cost and marginal cost. These three relationships are given in the figure. The first relationship is that when average cost falls, that is this portion, when average cost falls, marginal cost is less than AC. That is here, This is the average cost. This is the portion where average cost falls. In this case, margin cost is less than average cost. This is the first relationship. When AC is minimum, marginal cost equal to the average cost. This is the second relationship. And the third one is when AC increases, MC is greater than AC, as given in the figure. These are the three important relationships. When AC falls, MC is less than. When AC is minimum, AC equal to MC. When AC increases, MC greater. In this section, the conditions for a curve when it rises from left to right, when it falls from left to right, or when it is convex or concave downward or convex downwards are given. Here, two conditions must be satisfied for a curve. Either it rises from left to right or falls from left to right. The first order condition here, in this case, the curves rises from left to right. Here, in the both cases, it is rising from left to right. In this, the first order condition is that dy by dx, or the first order derivative should be greater than 0. And if it is of convex type, this type, then the second order condition must be less than, that is d square y by dx square should be less than 0. If it is concave like this, d square y by dx square must be greater than 0. These are the conditions for a curve which rises from left to right. In both cases, the first order condition is greater than 0, but in the case of the convex curve, it is second order condition less than 0, and in the case of the concave curves, it should be second order condition should be greater than 0. In the case of the convex, less than 0. In the case of the concave, greater than 0. Here, the condition for a curve which falls from left to right are given. It can be either concave downward or convex downward. In this case, the first order condition should be dy by dx less than 0. That is, the first order condition should be less than 0. In the case of concave downward, the second order condition must be less than 0, and convex downward, the second order condition should be greater than 0. These are the points to be remembered when we explain the relationship between the average cost and marginal cost. We can say that in the beginning, average cost is falls from left to right. Then this must be the condition. Then it rises from left to right. This must be the condition. From this, we can derive the conditions or the relationship between average cost and marginal cost. The relationship between average cost and marginal cost are given here. Given total cost equal to C, average cost equal to C by Q, and marginal cost is defined as DC by DQ. The first condition is when AC falls, marginal cost is below the average cost. When AC falls, marginal cost is less than average cost. Marginal cost curve lies below the average cost, or fall in marginal cost is higher than the fall in average cost. The condition for a fall or decrease in curve is the first order condition should be less than 0, that we have already seen here. It is a falling curve. It should be less than 0. Average cost falls or decreases means that d by dq of C by Q have negative sign. That is, average cost falls means the first order condition of this function must be less than 0. That is, d by dq of C by Q. This is the average cost function. This is less than 0. Now, differentiate this C by Q with respect to Q. C by Q. Here we need to apply the quotient rule. d by dq of C by Q equal to, we know the quotient rule, Q into the derivative of the C minus C into the derivative of Q whole divided by Q square. This is the quotient rule. That is, d by dq of C by Q equal to Q into dC by dq minus Q into dC by dq minus C into d by dq of Q. Here, that is equal to, this should be less than 0. Q into dc by dq minus C into dq by dq. dq by dq equal to 1. Therefore, this is Q into dc by dq minus C divided by the Q square should be less than 0, since dq by dq equal to 1. Now we can write this equation as this Q square is common to Q into dc by dq and C. Here Q and 1Q can be cancelled out. The remaining is 1 by Q into dc by dq minus C by Q square, or distribute this Q square to these two terms, Q into dc by dq minus C by Q square. That is, we distributed this Q square to these two terms. This is given here. 1Q will be cancel out here, that is 1 by Q into dc by dq minus C by Q square. Here this will be, we can factor out this Q from both, that then this will be equal to dc by dq minus C by Q. 1Q is taken out. Now this 1 by Q is the common factor. Then dc by dq minus C by Q. 1 by Q into dc by dq minus C by Q less than 0. This equation says that this into this should be less than 0. But we know that quantity can never be negative or less than 0. Therefore, it is assumed that this term is less than 0. That is, dc by dq minus C by Q is less than 0 still, since this is the quantity or the output. Output can never be negative, less than 0. It is a positive quantity. Therefore, it is assumed that this term is less than 0. That is, dc by dq minus C by Q less than 0. Or we can say dc by dq less than C by Q. This minus this less than 0 means this will be small one. That is, here if this is 4 and this is 6, we can say 4 minus 6 is minus 2. That is, this component will be smaller than this one. This is given here. That is the implication of less than. This minus this less than 0. That is, dc by dq will be smaller than C by Q. Then only we will get the negative quantity. This smaller and this higher. 4 minus 6 is minus 2, not 6. Minus 4 is a positive quantity. That is, this component will be less than the smaller quantity than this one. Then only we will get less than 0 component. Or here it is assumed, or it is given that dc by dq will be less than C by Q. What is this dc by dq? dc by dq is marginal cost. C by Q, it is average cost. Therefore, it is assumed that marginal cost is less than average cost. That is, when AC falls, marginal cost is less than average cost. It is proved in this section. Then the next relationship, it's the second one, is that when AC is minimum, AC equal to MC. When AC is minimum means dy by dx equal to 0. This is the first order condition for minimum. Either for maximum or minimum, if the first order condition is equal to 0. First order condition should be 0. That is, d by dq of C by Q equal to 0. In the same way, differentiate this function. You apply the quotient rule, we will get this d by dq of C by Q equal to Q into dc by dq minus C into dq by dq divided by the Q square. This should be equal to 0. In the same way, here dq by dq equal to 1. Therefore, the remaining terms are Q into dc by dq minus C divided by Q square, that equal to 0. In the same way, here we can distribute Q square to both terms and then factor it out. Then factor out the common term. 1 by Q equal to dc by dq minus C by Q equal to 0. Here also we can see that this component output cannot be 0. Therefore, it is assumed that dc by dq minus C by Q equal to 0. Or dc by dq minus C by Q equal to 0 means this will be equal to this. Then only we will get 0. That is, 5 minus 5 equal to 0. 4 minus 4 equal to 0. When both these two terms are same, then only we will get the equal. That means dc by dq equal to C by Q. What is this dc by dq? dc by dq is marginal cost. C by Q is the average cost. Therefore, marginal cost equal to average cost when AC is minimum. That is, when AC function is minimum, then marginal cost equal to average cost. The third relationship is given here. The third relationship shows that when AC increases, marginal cost is above average cost, or MC greater than AC. An increasing first order condition for an increasing curve is that the first order condition greater than 0. That is d by dq of c by q greater than 0. The same way, differentiate this with respect to c by q. You apply the quotient rule and factor out the common term. Then we will get 1 by q into dc by dq minus c by q greater than 0. It is also assumed that this component is greater than 0. dc by dq minus c by q greater than 0, or we can say dc by dq greater than c by q, or we can say here dc by dq is marginal cost and c by q is AC, therefore marginal cost greater than average cost. These are the three proof of the relationship between the average cost and marginal cost. We explain the relationship between the average cost and marginal cost in three important situations: when AC falls, MC below AC. Second one, when AC is minimum, MC equal to AC. Third one, when AC increases, MC above AC. The relationship between marginal cost and average variable cost is given here. The relationship between the marginal cost and average variable cost is identical to the relationship between MC and AC. Average variable cost first declines, reaches minimum, rises thereafter. When AVC is minimum, MC equal to AVC, and the relationship between the AVC and MC is given in the figure. This can be proved as follows. Total cost equal to total variable cost plus total fixed cost. Then take the differential of total cost with respect to Q equal to differential of total variable cost with respect to Q plus total differential of this total fixed cost with respect to the output. Since this is total differential of total fixed cost is 0, we can say that this is fixed or constant. Then it's got the differential of the constant equal to 0. Therefore, d by differential total cost with respect to Q equal to differential total variable with respect to dq. ddc by dq is nothing but the marginal cost, and variable cost can be replaced as or substituted as AVC into Q. That is marginal cost equal to, in the case of this, AVC into Q by dq. That is equal to, here apply the product rule, AVC, this U into V. AVC into dq by dq plus q into dVC by dAVC by q. Here we applied the product rule, that is u into v, that is u into the differential of second term plus v into the differential of first term, that equal to AVC plus q into dAVC by q. Since q dAVC by q is the slope of ABC, if dAVC by dq greater than 0, then average marginal cost curve will be greater than average variable cost. If it is less than 0, marginal cost will be less than average variable cost. If it is equal to 0, then we can say MC equal to AVC. These are the relationship between the AVC and MC.